Hi, Precalculus class. Welcome to our exponential and logarithmic equation. We have this problem here. Simplify log b equals equals 1 with the base a. Okay. This problem is coming to this main concept, the logarithmic. So the logarithm of x with base b is defined. Is defined as log x equals y with the base b. Okay, it's in that way. If and only if y, b is b to the y power is equals x. Okay, this is some rule where here x is greater than 0, x is greater than 0, and y is greater than 0, and b is different of 1. Okay, this is our main idea of our class. So after this, let's go to simplify our problem. Okay, so look at the problem. Look at the problem here. So the question is the form log with the log x equals y. So it's in that form. It's our equation. So rewrite in now. We have to rewrite the equation as an exponential equation. Rewrite as exponential equation. Okay, if we do that, we will have here log y equals 1 with the base 8. Okay, now just simplify. Y will be equals 8 with to the 1 power, so it's a 1 exponent. So here y is equals 8. Okay, this is our solution. The solution is valid only if the equation or the number in this case is 8. When the equation is true, when it's make the true equation. Okay, so in other words, the expression inside, this expression inside the logarithm into the original equation must be true. Okay, log, let's write log b equals 1 with the base 8. So here log equals 1, like that. All right, so here is plugging in the solution. And our problem is the solution 8, or b equals 8. b equals 8. So let's see another problem. I mean, there as a conclusion here, when you see this process here, this means the solution is valid only if the original equation values is it is true. So let's conclusion, write the conclusion. b equals 8 is a valid solution. Yeah, this is it's very simple. It's not hard. This is when we have one logarithm. Okay, let me show you another problem. This is maybe confused, but let me show another one. Let's write one more problem. And this example. So simplify log now x equals 2 with the base 6. Let's write 6 here. Okay. So what is the next step? Remember, next step, next step, the equation is in the form. What is the form of the equation? Okay, just write it. The equation is in the form. What is the form of the equation? So log here, x equals 2 with the base 6. All right, with the base 6. Okay, if we make the I will to write the process right here. It's very simple. Just continue right here. So next step is x equals we will have 6. Look at this, 6 to the second power. See, remember, and then and the other example we have 1 here, so then 1. So now it's to the second power. Okay, how much is x? So x is equals 36. Right there. See, so the solution is valid because the in original equation inside x is equals 36. All right. So log here. Let me write again. So log of x equals 2 with the base 6 here. So log let's write it here 36. Let's write it here 36, and then here write it 6. The base 6 equals 2. So here this step is plug in. Here plug in the solution. The solution x equals 36. All right. So our conclusion then, so as the conclusion, x equals 36. It is the solution, or it is is the valid solution. Is valid. Okay, it's valid. So that's it. Okay, let me show you the different kind of problems when we working with an exponential and logarithmic equation. So one more degree of difficult degree. So the next one. So the next one, we have to solve exponential equation using logarithms. Solve exponential equation using logarithms. Let's write problem like let's write this problem like this. 3 to the x power equals 4. This is exponential equation using logarithms. We have this problem here. So we have to remember the property, some property. Here, the property, we have here the power property. We have to remember to solve this this power property. We have log m n with the base b here is equals n. It's very important. Log b, I mean the base b, log m. Is you just read it. When b and m are positive, when m and n are positive and b is different of and different of from 0. Okay, so the common logarithm also we have used the common. This is another property, the common logarithm is another property, the base with the base 10. This is, we have to remember this kind, the rules. Is the logarithm like log with the base 10, we have the base 10 equals, I mean the logarithm x is usually writing without 10. So usually we write without 10. I mean just write only log x. Log x. So only like that, without x. So now keeping in mind this couple of properties, and then let's solve our problem. So notice here we have 3 and 4 cannot be easily written in terms of the same base, right? See right here. So take the common logarithm. We have to take the common logarithm. Remember the last rule? We have to take the common logarithm in both sides and solve for x. So then we have here, let's start it. 3 to the x power equals 4. All right, let's start it. Take the common logarithms on both sides here. Take, remember the last rule, the common logarithm in both sides. In both sides. So if we do that, we will have here the next step log. We have to write 3 to the x power here equals log 4, right? Log 4, right? This power, and then now we have to use a power of properties. Power of properties. Power of properties. Okay, if we do that, then this step we will have next step x log 3, right? equals here log 4. So this is now divide both sides by 4. Next step, divide by 4. If we divide both sides by 4, we will have here x, just write x log 4 divided by log 3. Might as well divide here in this step, divide both sides by 4 log 3. Yeah, that's called the step log 3. Now, yeah, divided by, yeah, this is the step. Okay, so now log, we will have log here, then log 4. If you do that we will have log 4 is check the number. We have 0 60 200 206. Okay, and also log 3 is equals 0. What is the answer? 47716. Okay, so now simplify this step. After this we have to simplify. We simplify, we will have, so the answer here, x, I mean, we could say this is a division. We have to divide here. You divide x, so and our division here mean let's write it. We have a small space here, but let me write it here. We have to write here equals x equals, we have 0.6206 and then 0.47716. Okay, you simplify this. If we simplify, the answer will be 1. Let's see. Yeah, it's 1.262. That's the answer. Okay, that's the solution to this problem. All right. So we use the common logarithm in both sides. Remember the common logarithmic property? So go a little back and then check the solution. Let me show you another one. Easier. Let's try to solve another problem here. It's very important. So let's write let me write 5. Let's write 5 equals 6 to the x power. So now take the remember here we have to take the common logarithm in both sides. Okay, the common in both sides. So take the common logarithm in both sides, then write here log. Let's write it here log 5 equals log 6 to the x. Okay, now this is a power of property. Power of property. Remember the power of property? The first rule that I wrote here. Okay. Okay. Now, if we write the power of property, we have to write it like this: log 5 equals x, right? X log 6. Okay. Now divide both sides by log 6. Now here divide both sides. We have to divide both sides by x log 6. X log 6. Okay. We will have here this step log 5 divided by log 6 equals x. Okay. Just we have to write this log here, log 5 here. Let's see, log 5 is not exactly, just write here 0.96 or 69 on 69.897. Okay, and then let's find the log 6. It is 0.77. Okay, 77 85. Okay, that's it. So now those kind of numbers we have to divide, right? So here this is step 0.69897 divided by 0.77815 equals x. Equals x. Now simplify. Okay, simplify. Yeah, I mean divide. Okay, divide those numbers. So you divide these. The answer is 0.89 875. Okay, equals x, right? So the closer 10 hundredths, so x is equals, you simply 0.898. So we don't have to write everything. Okay, that's the answer. So remember, this is a exponential equation, solution of exponential equation using logarithms. Okay, this is a second example. Let me show you another couple of problems belong to this topic, solving exponential and logarithmic equation. All right. So our problem now is we have let's write problem like this: log y plus log 2 equals 1. All right, we have this kind of problem. All right, how solve this problem? First, the logarithm of x here in this example, the x base. Let's write it here as because it's a different it's different topic, but it's belong to this topic. Here now is a logarithm equation with multiple logarithms. Okay, logarithm equation with multiple logarithms. Okay, that's the C. So the logarithm here. So the logarithm of x with again base b is defined. Remember, I defined it like that: log x equals y with the base b here, if only if b b to the y power is equals x. Okay, this is the rule where the x is graded. Here is x is greater than 0. B is a different 1, and y is greater than 0 2. Okay, those kind of clue. That's very important. Remember. So I already explained it to you. The common logarithm. The common logarithms. We don't have to write the base. Just write the logarithm, the number. Without, I mean, the base 10. We don't have to write the 10 in the base. Okay. This is what else about this topic? The product property. See, another thing. Product property here. We have to write product property. Okay, remember this. The product property. It is like this. Okay, in this way, log of m with the base b plus log n with the base b is equals a log. This is equals m n with the base b. Right? Where in this case, b, m, and n are greater than 0. b, m, and n are greater than 0. All right? So after this, let's find or solve our problem. So we have log y plus log 2 equals 1. We have to use the product property here. Product, like explain it to you. Product property. Okay, product property. If we use the product property and combine the logarithms, we will have log. This is next step here. Just write it here. We have log 2. Now log 2 y equals 1. Yeah, we have here combine and the logarithms. Okay, combine the logarithms. Now rewrite. Next step, rewrite this. Yeah, we have to rewrite as exponential equation. Very important this, and solve this step. So now log, let me write right here 2y is the same equals 1, but I am explaining the rule here. So this will be equals 2y equals 10x minus 1. as an exponential equation. See, very important. Now, 2y is equals, when you write it to the negative, is equals, we will have 10. It's 10, not negative. To the is positive right here, not negative 1. It's equals 10. When you exponent is the same number. So now y is equals, you divide it here, we have to divide right here. Both sides by 2. Yeah, by 2, and then we will have 5. So y is equals 5. Y is equals 5. Okay, we are here. The solution is valid. It's right. It's true, this solution. So because let's write it here. Log y plus log 2 equals 1. And the value we have to rewrite is equals, how much is y? Now we have to substitute y here. We have y. So log, how much is y? Y is 5. Log 5 right here plus log 2 equals 1. So just plug in here is plug it in. Y equals 5 in this step. All right. So our conclusion here. So y equals 5 is valid. It's a valid solution. All right. Let me solve another problem. Let's try to find the solution to another one. Let me write, let's write log, we have log x plus log 3, but this is 15, the base 15. The base 15 equals, let's write 1. Okay, as before, we have to use the product property here immediately. Product property. It's the first step. If we use the product property, we will have next step. Just rewrite it here. Log with the base 15, but log 3x equals 1. All right, we are here. Now rewrite that's exponential equation. Rewrite as exponential equation. Rewrite as an exponential equation. Okay, then we have already here, but the next step here, I will not write it again, the equation. So 3x here, 3x equals, we have 1 here, 3x equals, and this here, with the base, we have to write the base 15 with the 1 exponent 1. But very easy, not a big deal. Just write 3x equals 15. It's the same number. Every number to the first power is the same number, it's 50. So we have 50. Now you divide 50, we have to divide. So divide both sides by 15. We will have here x equals, how much is x? Equals 5. This is actually this is our solution. So we have to rewrite. Let me write it again. The problem: log 15, log with the base 15. Well, log with the base 15x log 3 equals 1. Right here is the problem. Just plug it in. We have to plug in 5. Right? I mean, x equals 5. Plug x equals 5. Here we will have, it's very easy. So log 15. So base with the base 15, just write here we have to write 5. X is equals 5. So log 3 equals 1. So the solution is valid. All right. This solution is valid for this problem. So the answer, our conclusion, x is equals 5 is valid solution. All right. So that's it. That was our exponential and logarithmic equation, solution of exponential and logarithmic equation. Belong to our precalculus